So in classful addressing, that is actually in the type A, B, C, right? So basically we divide into net ID and host ID. Okay. Uh, so in the class D and E, we doesn't have that concept. Only in ABC we have that net ID and host ID. Okay. So
Yes.
in class A, if you see here, like 1 byte we refer for host ID. Here we refer 2 bytes, and here we actually in D we refer 3 bytes. C we refer for 3 byte as a host ID, and remaining is net ID. Right. So
Yes, sir.
if you see, actually in the class A, uh, it is actually called as unicast. Okay, unicast addressing. Class A, B, C, right? We call it as unicast addressing. So class D and E, D we call it as multicast addressing. Okay, so
Yes.
like based on that, actually the number of blocks, right? We have to consider based on this. Here it is 0 to 127 only possible. Here actually it extended double, right? 256. I mean it is like a 16 bit, so it is actually 16,384. Here again further extended for 24 bits. 2 to the power 24 possible addressing is possible, right? So I mean different host ID is possible, correct?
Yes.
So usually when you see the settings, the network setting, I can just show you IPv4 settings in the PC itself. So you will get some idea. So whenever, okay, let me not present actually. Address. Usually if you go to the settings, right, you will see that like 255 dot, there is something called gateway or masking, right? So 255
Yes.
255.255.0. So that is actually it, that masking says like which kind of, which class of addressing you are using. Okay. So if like you can see that 255.0.0.0, then it is actually class A. If it is 255.255.0.0, then it is class B, correct? Or class
Yes.
C. Okay.
Sir, masking means?
Masking actually, we basically say to the addressing which is the class of the address we are using. It's like a kind of identifying which is the net ID, which is the host ID. So we are, I mean, we can give have the entire address, but the your laptop will not know, or like any device will not know which is host ID, which is net ID. So by masking address, we say that like which is host ID and which is net ID. We are guiding to that actually.
Yes.
So this notation, right? Whatever masking notation is there, we also call it as slash notation or CIDR. CIDR notation. Okay. So CIDR means classless interdomain routing. Okay. So another way is actually subnet. Okay. So here what we do, right? A large block of class A and class B address is assigned to a particular organization. Okay. Hello.
Yes. Yes,
So, I
sir.
mean, see 128.127 dot some value we will completely assign to particular group or institution, so that following numbers, right, like continuous following numbers, so this group will be using, because like if some random IP addresses and all we assign to organization, so it will be difficult for them to track. We assign like complete set of uh, net IP address itself. That concept we call it as subnetting. Okay.
Yes.
So now actually, if we say that like class A, class B, and this is assigned to only, like if you see that like class C is like assigned internally to the organization. So if this kind of concept, if we try to follow, right, then what will happen? Like address, eventually it will get depleted, right? I mean, more and more devices, more and more organization, it will be like address will get depleted. So for that purpose, what they have done, that is they introduced the concept of classless addressing. So here, right, we will not bother about which class it is. All the address can be assigned to any of the group actually.
Yes.
Okay.
Yes, sir.
So actually, in this case, right, we assign a block of in the classless addressing, we assign a block of address to particular group. So for instance, like if I have 205.16.37.39, okay, slash 28, if I say, right. So what people will do, like 39 minus 28. So it is like 39 minus 28 to 39. So that much address, right? It is assigned to a group. So this way, so this is a representation how we there say, but actually like from 39 minus 28 address to up to 39. So that many address we actually assign to a particular group. Okay.
Yes.
So another thing, easier way, right? Easier way, that is actually masking. Okay. So whenever they say 28, correct? Slash 28, I say. So basically we have to mask 28 bits. So 4448 again 16 plus 8, 24 and plus 4. So then rest all zeros. So when you add this, actually original address and this mask, so you are going to get this actually, whatever I said, right? 39 minus 28 value.
Yes, sir.
Got it, right? Getting that, what I'm trying to say?
Yes, sir. Yes, sir.
Okay. So actually, whenever I say that like I'm using this classless addressing, right? That is, the IP address will come into picture only whenever I want to connect that block, right? Like this assigning is actually like whenever I want to connect these devices into internet, because that kind of differentiation we have to do, right? So
Yes.
like it will be like no, it is a special addresses, but internal to that, right? They use their own addressing scheme. So for instance, like when I say that like 117.12.40.0/26, around 64 if I assign to internal network, right? Then in the internal network also, what I do, right? I will actually like divide into various further divisions. Like for example, like you have seen that like 192.16. So this kind of differentiation you see, right? So here again you will get like 65, 536 different addresses when you use particular class C addressing schemes actually. So what they do, like whatever we have to connect globally, they will use like class A and class B. Internal to the organization, they will go with the other addressing schemes.
Yes.
So we'll take one problem.
Yes.
An internet service provider, ISP, granted a block of addressing starting from 190.100.0/16. So this addressing space has to distributed among 3 customers as follows. First group has a 64 customer, okay, and each customer needs 256 address, okay, and second group has 128 customer and each customer need 128 address. Third group again it has 128 customers and each group needs 64 address.
Yes.
We have to design sub block and how many addresses are still available after allocation we have to find. So what is the requirement of group 1? They need 256 address. Okay. So 256 means in terms of bit, if I want to find in terms of bit, it is actually 8 bits, right? 8 bits. Correct?
Yes.
Log 2 to the base 256. That is 8 bits.
Yes, sir.
So the prefix length, like out of how many bits we have in the address, we have 32 bits. Out of that, 8 bits we want for representing this group 1
Other-
customers.
Yes,
So
sir.
our subnet mask will be 24 bits, correct?
Yes, sir.
This way. So first customer we will assign with 190.100.0.0 with subnet mask of 24. Agree?
Yes, sir.
So in this way, actually, like what happens, like 0, 1, 2, 3, so on, up to how much? 255 we will give. For each customer requires 255, right?
Yes.
So here 0 to 255, and this next customer it will be 1, 2, 3, like that, up to how many? 64 customers.
Yes. Yes,
Getting
sir.
right?
Yes, sir.
So if that is the case, so total how many actually addresses are gone here? 64 customer into 256. So total 16384 address I am using, correct?
Yes, sir.
So can you tell me in the same way for the second customer?
Yes, sir. Once.
Second group, not customer. So second group has certain customer, and again they will have particular number of customers. So that
So 7 bits of log of base 2 into 128.
correct. That is 7 bits. So our mask is 25, correct?
20, 24.
25 bits. 25. So it is 32 minus 25. 32 minus 7. 32 minus 7 we are
Yes,
doing,
sir. Yes, sir. 25 bits. Yes, sir.
correct. So 25 bits. So mask
Yes.
is actually 190.100. So here actually if you have seen 64 is already done, right?
Yes, sir.
So it starts from 64. So here it will be 63 up to 63. Here it will start from 64, then dot 0. Correct? And
Yes.
this will be keep on happening up to 128 here, correct?
Yes, sir.
Not 128. Here it will be 256 itself. 256 up to 256. No, actually it is 127 because 128 and each customer has only 128, right? So it will be 0, 64.0 to 64.128, correct? And for the second customer 64.127 it is 127 to 64.1256. So like that, finally 127 127 to 127.127 to 127.256, correct?
Yes, sir.
So total that way actually group 3 also you have to design. So here actually 16384, here again 16384, here finally 64 into 128, that is half of that. This 8000 something will come.
Yes, sir.
819.
Yes.
So if you actually how many numbers they grant? 16, correct? So 2 power 16 we saw. So totally 65,536 addresses are granted. Apart from out of that, like you add everything, we used only 40960. So finally, how many is available? 24,576 will be available.
Yes, sir.
Got it, right?
Yes, sir.
So in whole, like the internet is divided into packet switching, circuit switching, message switching. Okay.
Yes.
So if you see the difference, the message switching is previously used for the telegraph network. Circuit switching in telephone network, packet switching is internet. So usually in the telegraph, you know that like they used to have Morse network. So circuit switching, like olden telephone, they used to have like both analog and hybrid also. For especially for voice data. Now it is like everything is binary. So transmission is actually digital data over different transmission media. Here analog and digital mixed. So here it is actually a digital data generally through some Ethernet network.
Yes.
That is the basic difference.
Yes.
So tomorrow we have to see some datagrams and IPv4 addressing mechanism. Okay.
Yes.
Okay. Okay. We will little discuss on datagrams also.
Yes. So can you upload this recording also?
Sure. I'll upload both.
Oh, okay. Sir. Thank you. Sir.
Wait for some time. I think I'll take another topic. Maybe another
Yes.
5-10 minutes. Okay.
Yes.
So next actually datagram, in the sense like how packets from one destination to another destination travels. Okay. So if you see here in the network layer, it sends to the routers, right? Routers. So these whatever you see 4, 3, 2, 1, these are packets.
Yes, sir.
I said in the connectionless protocol, it can travel in any way, right? If you see here 2, it travels like this, and 1, it travels like this. 3, it came here, came here, came here, travels like 4, actually it came to here. But here we received 1, 3, 4, 2, correct?
4, 2. Yes.
So receiver, what it does, it takes this and sort it again.
Okay. Yes, sir.
And actually in the router, what happens, we will have like a destination address, like source address and destination address and data. So here actually sees like what is the destination address. Based on that, it will push into particular path or port corresponding to it. Again, it will add the source address and destination address and it pushes out the data. Okay.
Yes, sir.
This is how actually packet switching happens.
Yes.
That is in the connectionless protocol.
Yes.
But in the connection based approach, right? So whenever I want to send the data, so it actually dedicates one path to that, and in that path only dedicatedly it goes. And here there is no issue of because only one path, right? So there is no issue of jumbling. Sequence number is maybe like we can skip in certain scenarios, exceptional scenarios. Okay.
Yes.
So there will be another way also in the packet switching with the connection virtual circuit network or connection based protocol. So what we do, like from here to here we will send and we will get some acknowledgement. So that is also one way of sending.
Yes, sir.
So connection-less protocol we usually say as datagram subnet. Okay. Connection-based one we will say virtual circuit subnet. Okay.
Yes.
Yeah. Next, tomorrow we will see the performance of this network layer. Like we have some delay computations, how to find the address, all this stuff we have to discuss. Okay. So tomorrow we will discuss.
Yes.
So tomorrow with that, like I'll try to close network layer and then transport layer will be. Okay.
Yes, sir.
Okay. And
Nice.
what we'll do, like
Yes, sir. Yes.
I'm going little fast now, but like what I'll do, once we cover everything, right, we will get some time to revision based on the question papers and numericals we can expect. So that way we will plan. Okay.
Yes, sir.
Oh, thanks.
Thank you.